Objective A. Determine if a polynomial is a perfect square trinomial or a difference of squares. Number 1. X squared plus 9x plus 16. It has 3 terms, so if you're going to pick a choice, it's going to be either a perfect square trinomial or neither. It's not going to be a difference of squares because that requires you to have 2 terms. To check out whether or not it's a perfect square trinomial, one thing we can do is we could check out the first term and the last term. The first term right here, this is x squared, so the first term, x squared, is a perfect square. And then check out the last term. Last term is 16. 16 is the same as 4 squared, which is also a perfect square, so it looks promising that it might be a perfect square trinomial. The next thing to do is checking out the middle term. Middle term, if you remember, for a trinomial to be a perfect square, it has to satisfy a squared plus 2ab plus b squared. So it has to satisfy this format. By looking at the middle term, which is 9x, I would say it's not 2ab. Why is that? Because if it satisfies, a has to be x, b has to be 4. And that basically means our 2ab, the term in the middle, has to be 2 times x times 4, which is ax. But what we have is 9x. So your answer to number 1 will be neither. Number 3, x squared minus 81. I think this one is pretty easy to see that x squared is a perfect square, 81 is 9 squared. So this one will be a difference of squares. Moving on to objective B. Factor a perfect square trinomial. So we have 2 formulas to remember. A squared plus 2ab plus b squared equals a plus b squared. The other one is a squared minus 2ab plus b squared equals a minus b squared. As long as your trinomial satisfies either one of these 2 forms, then we could factor into a perfect square trinomial. Looking at number 5, x squared minus 16x plus 64. The first thing to do is check whether or not this is in the desired form. That means we have to figure out a and b. First term is x squared. That basically means a is x. Last term, it's 64. It's a squared, so our b is 8. But that doesn't guarantee that the entire trinomial satisfies the desired form because we have to check the middle term. The middle term is negative 16x. So you want to make sure that this one satisfies one of the desired form. Since it's negative, we will look at the second formula, which is this one. We will check if the middle term satisfies negative 2ab. So let's calculate negative 2ab first. That would be negative 2 times x times 8, which is negative 16x. And that's exactly what we have in the middle. Therefore, this is in the desired form. We can use the second formula to factor it. Then this one just becomes a minus b squared. A is x minus b is 8 squared. Number 7, x squared minus 15x minus 25. So it's the same idea. We'll be looking at a and b first. X squared, so that means a is x. Negative 25. Because it's a negative 25, it's not a perfect square. If you look at the formula, both of these has to be plus b squared. So that basically means we don't have a b. We don't have a b. Therefore, this is a prime. It's impossible to factor this at this moment. Number 9, 16x squared minus 40xy plus 25y squared. Same idea, figure out a and b. 16x squared, it's the same as, you could rewrite this as 4x squared. Therefore, a is 4x. 25y squared, you could rewrite this as 5y squared. So our potential b is 5y. Then we will check the middle term. Since it's negative, we're looking at negative 2ab equals negative 2 times 4x times 5y. Let's calculate. Negative 2 times 4, negative 8 times 5, negative 40. So we have negative 40xy. So this is indeed in the form of a squared minus 2ab plus b squared. Therefore, we could calculate the factor form right away. It's going to be a minus b squared. A is 4x minus b is 5y squared. Number 11. 3x squared minus 30x plus 75. First thing to do is checking out whether or not we have a desired form. This one might be a little bit tricky. So if you just look at the first term and the last term, you will see, oh, none of them is a perfect square. Do I just write prime? Well, the answer is not. What you can do is you can factor out a GCF. So do not forget that for some trinomials, you could factor out GCF. The GCF of this trinomial is 3. Once you factor out 3, we will have x squared minus 10x plus 25. And now let's look at the trinomial inside the grouping symbol again. First term tells us that a is x. Last term tells us that b is 5. And let's check out the middle term. Since it's negative, we're calculating negative 2ab. Negative 2 times a, which is x, times b, which is 5. That gives us negative 10x. And it's indeed what we need. Therefore, it's in the desired form. We factor it. So first, copy down the GCF 3. And then you're going to write down something squared. Inside the something, it's going to be a minus b squared. A is x, minus b is 5, and that's it. Objective C. Factor the difference of squares. For this part, you need to know one formula in order to factor the difference of squares. And I would say this formula is extremely important. A squared minus b squared. So this is the expression that describes the difference between two perfect squares. According to the formula, it's the same as the product of two factors. So you have a plus b and a minus b. These are the two factors. This formula is also very easy to remember if you look at it. A plus b, a minus b. I highly recommend that you remember it as soon as possible. Let's look at number 13 and see how you can apply this formula. Number 13, 49x squared minus 100. In order to use this formula, you need to make sure that both of the two terms are perfect squares. First one, 49x squared. It's the same as 7x squared. And then you have a minus. 100, you could also rewrite that as a perfect square, which is 10 squared. Therefore, we can use the formula a plus b times a minus b, where a is 7x, b is 10. Number 15, 16xy squared minus 4x cubed y squared. Just by looking at these two terms, you might notice that they're not perfect squares, but do not forget in number 11, we factor out a GCF. So usually, if you can factor out a GCF, do that first. The GCF in number 15 is 4x y squared. Once you take out this GCF, we will have 4 minus x squared left inside. And then we'll be focusing on the two terms inside the grouping symbol. 4, you could rewrite that as 2 squared minus x squared is already a perfect square, so you just copy it. And then this 2 squared minus x squared, apparently it's in the desired form a squared minus b squared. Then we can use the formula on the top right. 4xy squared. Do not forget to copy this GCF. And then you have two pairs of grouping symbols. Inside of the grouping symbols, you have a plus b and a minus b. 2 plus x, 2 minus x. Number 17, x squared plus 8. This one, we cannot factor it. Why? Well, there are several reasons. One of the major reasons is the sign in the middle. This is a plus sign. It's not the difference between two terms. So it's not going to be the difference between two perfect squares. Additionally, this 8 is also not a perfect square. So we will just write prime. Number 19, 16x to the 4th minus 1. This looks promising because we have a minus sign in the middle, and we just need to check whether or not on the left and on the right of the negative sign we have two perfect squares. 16x squared, we could rewrite that as 4x squared squared. Copy the minus sign, and then we have that 1. 1 is the same as 1 squared. So this is in the desired form of a squared minus b squared. We use the formula, and we have a, which is 4x squared, plus b, which is 1, times a 4x squared minus b, which is 1. And some people might say, okay, that's the end of it. However, that's not the end of it. For the first factor, 4x squared plus 1, it's the sum of two perfect squares. We don't have a formula for that, so it's a prime. You just copy it. But for the second part right here, 4x squared minus 1, it's actually another difference of two perfect squares. Because the 4x squared, you could rewrite that as 2x squared minus 1, which is 1 squared. So we have another difference of two perfect squares. That means we have to use the formula again. Copy the first factor, 4x squared plus 1, and then you use a plus b times a minus b to complete the factoring. 2x plus 1, 2x minus 1. So for number 19, it indicates that in some situation, you might need to use the formula multiple times in order to factor completely. Objective D. Solve applied problems involving factoring. 21. The height in feet of a watermelon dropped from the top of a building 220 feet above the street is given by this expression, where t is the time in seconds, and they want you to factor this expression. Personally, I really love watermelons, and it will make my heart broken if I see a watermelon dropping from the top of a building. Let's factor this expression. 225 minus 16t squared. Write it out. It looks like a difference between two possible perfect squares. Is that the case? Well, it is. 225, if you remember, it's 15 squared. And then minus 16t squared, that's 4t squared. Therefore, it's in the desired form of a squared minus b squared. You could use the formula a plus b times a minus b and write the factor form as 15 plus 4t times 15 minus 4t. All right, thank you for watching.